Sorry for the loud all right, because I just jumped in, but I think we're back and good to go. Had to restart. And I have to do one more thing. All right, let me get this rocking here in the chat. Okay. Sorry, a little confusion there. Had some issues. Had to restart. AirPods wouldn't connect up, and believe me, the audio without them is pretty bad. So they got that going, so that's good. All right, so we just going to kind of recap here. If you haven't watched the first stream, I highly recommend you do. It kind of gets you buried in. But what we've done is we've created an application. It's an ASP.NET Web API. We've thrown some code into it so that we can run and test it locally. We've thrown in Swagger, so we're using NSwag, so we can bring that up in. Created a message contract, and right now we're just using the Mediator part of MassTransit. Mediator is kind of a new thing. It's an entirely in-memory way of dispatching without a transport at all. I mean, MassTransit has an in-memory transport, but Mediator doesn't even use a transport, so no serialization, none of that. Makes it extremely fast. I mean, on my gaming rig, I get like 650,000 messages a second dispatch, so it's clearly not a bottleneck. Yeah, so that's cool. So let's just go over what the code we have here today to just kind of get everybody kind of caught back up. We have the sample API, which is a web API. We created an order controller. The order controller is pretty simple. It has a single method right now, which takes a post. It uses a request client to send a submit order message to a consumer that we've created. And then based on whether or not the order is accepted, rejected, returns the appropriate response code to the HTTP caller. If we look at the consumer, we can see that the consumer is pretty simple. It doesn't actually submit an order and put a product on your front porch yet, but it's doing a quick little test and either rejecting it if test is in the customer number, or it will return and accept it if the order is there. So pretty basic and entirely in memory right now. And there. So at the end of the last, or the first installment, so this is the second, so right on. I think the next step is we've created this project and just kind of shown that you can create a consumer inside a web project, so you can decouple your controller from your backend processing logic. And the nice thing that this does is it gives you kind of a gateway to moving towards a fully distributed system. So like right now, we're still running in the ASP.NET process. We're building our code. We haven't had to introduce a message broker into our infrastructure, but we're able to decouple our consumer in a way that lets us do that in the future. We've created our projects separately. We have our message contracts and our messaging components in separate assemblies. And our web API is just the controller, and it's going to deal with, the JSON formatting for the view models, things like that for the web API. That gives us a nice decoupling, kind of a way to grow into messaging without, going all the way in to requiring infrastructure to be set up and all that. It lets us test. It lets us kind of get there. So what I want to do now is I want to actually create a separate service that's going to use RabbitMQ and actually break this out of process. And one thing that I did note is after I do that, I'm then going to show how to introduce unit testing to it by creating a unit test project and show how to use the test fixture to test this same code with an in-memory test bus so that I can verify that message serialization and things like that all work together. So if anybody, does join and have a question, great, pop it up in the chat. We can hit it up there. I'm not currently watching Discord or anything else, so if you're in the Twitch chat, that's the place to go. Drew has been kind enough to post the MassTransit link up there, which is great. So to set up the RabbitMQ process, I'm going to do this in a couple of steps. First, I'm going to create a new console service. So I'm just going to go out here and do the new project because it's there. I'm going to say sample.service. I'm going to create this as a NetCore app 3.1 console app, console application, sample.service. I'm going to create that up. And one of the nice things about .NET 3.1 is that they actually have the new generic host. And this, if anybody knows the history, I wrote a service program called Top Shelf years ago. I mean, like years ago, but then again, MassTransit's been years ago too. But it basically made it very easy to create Windows services. And, Top Shelf was kind of like the super easy way to do services for a long time. Now that .NET has, in .NET Core, we have the generic host, a lot of the need for Top Shelf, in my opinion, has kind of gone away. You can create a console application that will install as a service. It'll run as a daemon on Linux. And it has all of the Microsoft extension stuff built in. So configuration, command line, environment variables, everything is all built in, and logging, all of that just works. So I don't see a need really to work with Top Shelf at this point. So all of this I'll be doing with the generic console host. So I am going to drop into my cheat sheet for a little bit. So give me a second because I had to restart my computer to get audio back up. But there is a sample online called Sample Batch that has the Sample Batch service, which uses the generic host. So I'm literally just going to go steal code from there to get the baseline references set up. So I'm trying to remember what the package of this thing is. I want to say it's like hosting Windows services, login configuration. I think it's like all of this stuff. So I'm just going to cheat and go back in there. I'm going to go into my sample service and edit the project. I'm going to drop a literal bomb of package references here. I guess I do have to put this in an item group. And it's actually faster to do this than using the NuGet packet manager. Just cut and paste, rock and roll. Save that out. I think there was one other piece I wanted, the latest language stuff. Otherwise it gets mad. I don't think I need anything else from there. I'll reference my projects later. Yeah, all right, that should get us going. So we'll save that. We'll go to our program CS. Program CS is going to need some work as well. So we'll exit out of that and I will go to program.cs. You're seeing all of this very raw and unfiltered because it is completely unscripted. I literally woke up this morning and said, hey, you know what would be fun? So that's where we are now. Man, there's a lot of code involved in doing all this, isn't there? All right, we'll just snag all this stuff and yank out what we don't need because a lot of this is extra. All right, so we'll go back into here. We'll go to our program.cs. We'll dump the planet in there, and then we'll kill everything we don't need. Put an async task here. Get that reference. Yep. Probably not going to need that. Probably not going to need that for now. We'll get to MassTransit shortly. We'll yank all this code out. Not going to need it. We're going to not need that. We're definitely not going to need that. Don't even know what that is. Oh, logging. Logging is good. I like some logging. Got our use Windows service. Okay, let's go steal our configure bus code. We're just going to take the RabbitMQ code for now. We will add that down here. Static void configure bus. We'll leave that there. We'll just end up probably hard coding a lot of that stuff. Get rid of that. This will be our anchor. So since we did reference a new project here, we're going to have to add references to our component, because that's where our components are. That's going to get us our bus reference. We don't have that yet. So the MassTransit components project, when you look at its dependencies, it's currently using MassTransit 623, and that's it. So it doesn't have any of our transports loaded, which would be fine. If we were going to use in-memory, that would work, but in-memory only works within one process, and we're going to try to get our API to talk to our separate service. So I'm going to have to go into the NuGet packet manager here and add some NuGet packages. So let's get masstransit.extensions.logging. Whoa, that's not it. We don't use that anymore. MassTransit extensions dependency injection, so our configure services work. So we'll get that one. That'll bring in a few things for us. We will get masstransit.RabbitMQ, because we're going to do this with RabbitMQ. And I'll probably have to snag a couple other pages from somewhere. Don't need that, don't need that, don't need that. I am just going to use the local host. Keep it as simple as possible. The MassTransit console hosted service. I think I need to go grab that. So when you're using ASP.NET, and we'll get into that, it has a class already built for you to run as a hosted service. In this case, because I'm doing a console app, we don't really, we have the ASP.NET Core package for MassTransit, but we don't have one for like console hosted service stuff yet. So probably something that when we get around to getting the host to where there's a standard host, it makes sense. But for now, a simple MassTransit console hosted service, all it does is, because it's an I-hosted service, it gets added to the container. The .NET Core generic host will actually start this up for us and call start async, which we'll use to start our bus, passing it the cancellation token if they decide to give up on us. This is going to need iService provider since we're using MSDI. The endpoint name formatter. I don't know where we get that. We don't really need that, so we'll get rid of that. We will change this to return bus control. We will add our submit order consumer here. So if we go back to the code in the startup CS that we did in the first installment here, you can see that when we configured MassTransit, we said add consumer, submit order consumer. We said add mediator. We said add request client. Those things were all added explicitly. MassTransit can actually scan assemblies and find like types for you, so you don't have to register every single one of them. In this case, I'm going to use the add consumers from namespace containing, pass the submit order consumer, and then just configure the bus by calling add bus, because here I said add mediator. I'm going to change the web API one shortly to use the same configuration. But for now, I'm going to call add bus with configure bus, which literally all this is doing right now is just saying create using RabbitMQ and configure the endpoints. So the way MassTransit container support works is when you add consumers, sagas, things like that to the container, MassTransit keeps track of every one of those registrations. And then when you call configure endpoints, by convention, it's going to go out and figure out names for all of the queues, which consumers to put on the queues, and it's going to do all that work for you. So it'll, put everything on its own queue, run it the way it's supposed to. If it's a saga, it puts it on there. You can configure the saga repositories. If it's a routing slip activity, it creates an execute and compensate queue for it. So it does all of that work for you. The one other thing I may do here is I may services.try add singleton kebab case. I like the kebab case style of formatting, which is snake case, but with dashes instead of underscores. So I'm just going to register that in the container, and then it's going to by default use that because it's going to discover it in there. I don't know what this contains is supposed to be. Is that a link thing? Probably system.link, I'm betting. Look at that. All right, I'll clean that up. All righty. Never check your text messages when you're streaming. Just don't do it. It's a rule. Go ahead and close that out. Okay, so I have this going. Check is green. Looks like it's going to compile. Whether it will start or not is another thing. So we don't have RabbitMQ yet. So we're going to, we're on a Mac, which is awesome. And I'll only say that like 12 more times. And I'm going to check what I have running in Docker. Currently, I don't have anything in Docker, but I want to create a Docker compose for this. So I'm in the service folder, and this is that sample batch. So if I go, is it one more up here? Let me check. Yeah, so I'm just going to copy this because I'm lazy. I'm going to copy this to home sample Twitch docker-compose.yaml. Then I'm going to go back to here, and I'm going to look at that Docker compose file and take out the stuff we don't need. So yeah, we got some RabbitMQ. We don't need SQL Server yet. We don't need Redis yet. We aren't there yet, but we are going to put RabbitMQ in here. I think this is the right one. This will work for now. So if I come back in here, Docker compose up, this should start up RabbitMQ. Cannot create container. The container is already in use. Oh, you don't want me to use the same name. Okay, well, we can call it something else. Container name, Twitch, RabbitMQ. Again, creating Twitch RabbitMQ, attaching to Twitch RabbitMQ. All right, we got RabbitMQ started up. Looks good. Go back to here. Go back to source, cd sample.service. And let's do, I think I need a logging configuration. I think that's the only thing that's going to screw me up here because I don't have app settings. I don't have any of that. So let me take a look at my other folder here because that's what I'm going to do. How about app config? Don't need that yet. App settings. Yeah, we'll move that for now. Source sample.service. Okay, so now I got an app settings.json. I don't need all this. I don't need all this. Don't need really any of that. All I really want is the log level, but that's fine. Don't know if there's a thing to set in here. Build action, content. Sure. See what that does. See what that does. So now if we go back in here to, let's see, that's my RabbitMQ. It's my sample service. So here's my service. There's the app settings JSON. What just happens if I try to run this? Because why not, right? Content root path. Nothing started. Okay, so let's go back here. Let's go look at the program CS. We got the console hosted service. We got the configuration. We got the bus. App settings. Log level debug. That looks all right. Let me see what I messed up here. Oh, we probably need that. So what was missing is I don't think it was actually copying the app settings out, so I wasn't actually getting log data. We'll try it this way and see what happens. Let's try it again, because it looked like I only had info on that one. If I run it this time, there we go. Now we got debug output, so that was the deal. Do I need -- console? Yeah, probably, but I think it figures it out, because I don't know. I guess maybe I should have run it that way. It does say Control-C to cite down, though, so that's good. Thanks for that. So now I have, you can see, MassTransit's going to dump out a bunch of log files here. So debug, I've got hosting starting, configuring consumer, sample components consumer, submit order consumer on submit - order, starting the host by default, because I didn't configure anything specific for the host. MassTransit will always try to connect to localhost with guest, which is the default RabbitMQ. So for now it works because I don't even have to specify host, because that's how I have it set up. You can see that it declares an exchange. The name is submit order, because the way MassTransit's topology works, and I'll bring up RabbitMQ in a second and show that. RabbitMQ has exchanges and queues, and it creates a matching exchange name for the queue name. So instead of sending directly to the queue, it sends to an exchange first. It gives us some flexibility in being able to tap into messages and kind of do some tricky things with them, which is kind of fun, but beyond the scope of this. We bind the queue submit order to the submit order exchange. We set a prefetch count, which the default is 16, which is based on something like the number of cores. The consumer OK means our consumer is connected. So if we go into our browser now and go to RabbitMQ, log in with guest, and we can see we're running RabbitMQ 383. We have a queue called submit order. When we bring that queue up, we see that nothing is happening because there's no traffic on it, but we do see that there's a connection to it, channel right here. It has the consumer tag, prefetch count, just as we saw, ACK required. Bindings, the inbound binding is the submit order exchange. And from here, you see something else. So this exchange, submit order, has a binding to the submit order queue. It also has an inbound binding from sample.contracts.submit order. That's the message type that the consumer on that endpoint is listening to. So MassTransit will declare exchanges for every message type based on the name of the message. And this is how publish works. When publish works within MassTransit, when you call publish, publish will actually send the message to that name, and then any subscriptions to that or connections to that will actually receive the message. So when it goes to this exchange, that's bound to the submit order exchange, which is then bound to the submit order queue, which then has the consumer on it. So that's how publish routing works with RabbitMQ. Every broker is a little different. This is how we do it with MassTransit and RabbitMQ. So if I click on that channel, I can actually dig in and see the details about the consumers. There's only one consumer on that channel. Typically, MassTransit will create a channel per consumer, or per receive endpoint, I should say, so that it's able to track all that. And then the connection that we're on, if you actually go and dig into that, you can see the client API is MassTransit. The connection name is .NET, which is weird. I guess it takes the process name. Pivotal Software, because they bought RabbitMQ. The host name that's actually sending it. The MassTransit version, the .NET version, the platform of .NET, the product. It just gives you a little detail so you can kind of see. It should have a host name, and I don't know why I don't see one there. Oh, because that's the IP address. Never mind. Okay, so that's all good. .NET version 3.12. Oh, core app, yeah. So that's kind of what we see on the broker. We see a little bit of activity, a little bit of message activity, not too much there. If we go back to here, when we actually stop our service and it exits, we'll see that consumer disappear, the connection's gone, and everything's cleared up. So we have our service, it's connecting to RabbitMQ, and it's ready to receive a message. Now we have to figure out how to send it a message. So if we go back to our code, We will close this out, close this out, close this out. Let's actually go to our startup CS. And now we want to get rid of this add mediator call, and we want to put add bus. So we're going to actually add a bus for this. And in this case, we'll just configure the bus internally. We will say provider bus.factory.create using. And by default here, we have in memory because we haven't added RabbitMQ yet. So let's go to our API, do our manage NuGet packages. Here we have RabbitMQ. We can add that to sample API right here. And now we can say create using RabbitMQ. Now we really don't have to configure anything here because the default host is going to be localhost guest guest. And I don't have any consumers, so there really is nothing for me to put in here. I can leave this completely empty like this. If I did have a different host that I wanted to configure, I would come in and put something like x.host, and I would put your server, and maybe I would put the name of a virtual host or something like that, /my vhost, whatever. I'm just going to leave that out for now because honestly, I don't need it. And if I don't need it, let's get rid of it. It's noise. That's the only thing I'm going to change. So it was add mediator. Now it's add bus, and it's going to be talking to RabbitMQ. I haven't changed any of the code in the API controllers. I should take this out because I don't want to run the consumer here. There's no endpoints to configure because I'm just doing the requests from this box. So if I take that, I go out here and I create another window. .NET run. Content root path. Oh, something is missing. I didn't get any good debug messages, and I know I should have. I didn't do one thing on here, and I think that's probably why. So if I go back here, I go back to the startup. So I've added the bus and I've added MassTransit. The other thing I didn't do, which I should probably do, is try add singleton kebab case formatter.instance. Don't need that here because I'm not hosting any endpoints, but I'm just doing it because I don't want to forget. But I need to say services.add MassTransit hosted service. With the mediator, it's all in memory. There isn't a transport, so there isn't anything to start. It's just there. It's pure in-memory dispatch. But with the bus, I actually have to add the hosted service so that I can get the bus control started and stopped, just like I did in the console service. So this will add that to the ASP.NET runtime. The other thing it will do is it will actually configure all the health checks so that when you hit like the /health or /ready endpoints, if you configure that stuff in your web API, you can make it so that your process will come up and then it will show health checks so that like if you're using some sort of monitoring in your Docker container like Prometheus or something like that, that it would actually let you monitor that service. And if it gets in a bad state from a receive endpoint, you could recycle that instance and create a new container instance. Not going to go into that right now, maybe later, but that's why it didn't start. So I'm going to add this. I'm going to call .NET run. And now we see MassTransit starting the host, connecting, and it connects to that, and I have a connection to the broker. That's it. That's all it does. It isn't consuming any messages, so there aren't any receive endpoints. It's doing literally nothing. But if I open another window, which let's see here, this one right here, and I run my service, which is going to be running a separate process, I have my service running here. I have my code that I can get rid of here. I have my website running here. I have my Windows service running here. Docker Compose is over here talking about connections and all that fun stuff. That's great and all. This is the website of the service. This is the service. This is the API. So now if I go back over to the browser, first, let's look at RabbitMQ. I can see I have two connections. One connection, this one looks like it's from assemblysample.api, so this is my website. I can see the channel that it has one channel, no consumers, nothing. There's nothing there. If I go to queues, I still have my submit order queue. The submit order queue still has the consumer on it. One consumer running, that's all there is, nothing else extra. I have the one exchange for the message type, and I have the one exchange for submit order. That's all that's there. So now, within this new tab, if I go to localhost 5000, 1/swagger, I can now go into my order API. So here's my post. This is where I'm going to create an order. So let's go through that create order process again. Get myself a GUID. I think it's funny that Visual Studio's had that generate GUID since like Visual C++ 152 or something, and yet everybody still has a tool to generate a GUID in the window. I think that's just like awesomely familiar. I'm going to go to try it out. I'm going to punch in a GUID. I'm going to put in my customer number of 12345, and I'm going to hit execute and hope that everything works. And it did. I got a 202. My request was accepted. I have my order ID, my customer number, and my timestamp. All that looks good. If I go back to my console window, I can see that my service did some stuff. What did it do? Oh, it declared an exchange name of that crazy word right there, of fan out auto delete, which if I go back and look at my broker, I have another queue. I have a queue called crazy name base 32 encoded GUID. And this queue, the consumer is, if I go back, this looks like the connection for that is my sample API. So by having the sample API, the website had to create a temporary queue so that responses could come back. So the web API site created a temporary queue, connected the response consumer to it, which is entirely under the covers by the request client, and then sent the message to the submit order queue. If we look at the bindings on here, there are no bindings. It's just the default binding from the exchange to the queue. And the reason is because responses, when we send them, they have information in that message envelope that tells it where it is. So let's go back here again, and let's do something even more interesting. So we have the sample API up. We have the service up. I am just going to kill the service. Done with it. So I've stopped, and you see it does a bunch of shutting down the consumer, stops the queue. Nothing is connected to my RabbitMQ now for now. So if I go back to the queues, submit order is there, no consumers, nobody's listening to it. But I'm going to go back to my website, and I'm going to submit a new request with customer number 123456. You can see it's sitting there, it's loading, it doesn't know what it's going to do, it's waiting. If you look at the log, it's sent the message to the submit order exchange, which I should probably point that out. It sent the message to the submit order exchange because I didn't tell it where the address of the server was. So essentially the request client is reverting to a publish, and it's publishing to samples contract submit order that message, which is then being received by the endpoint. And you can see I got a 5 error back in the website, or a 500 error, because there was a timeout waiting for the response. And that was the request ID. If I go out and look, the request ID is in there. The service was down, and because I was waiting for a response, it timed out waiting for that response. If I go back and look at RabbitMQ and I look at that submit order queue, there's no message there. Well, where did it go? So let's try to do it a little quicker this time and not, go off on a tangent about other things. So we'll put a 7.8 in here. We will execute. Now we will go back here and we will look at the submit order queue. And there's one message in there. No one's receiving it. I'm going to go ahead and get this real quick so we can look at it. But that message is sitting in here. The request isn't there. The service isn't going to pick it up. If I actually were to go out and start up that service and do it fast enough, it would actually process it and potentially give it to me. Oh, and there it is. So I was actually quicker than the 30-second default request timeout that was passed up. So we can see I have the response, my 78123456 that I just sent. But if I go back and look at RabbitMQ, I grabbed a copy of that message while it was still sitting in the broker because the service was down. I grabbed a copy of the message because it was sitting in the queue, and then I started the service, which then consumed the message and sent the response back to the website. And I did this because I wanted to kind of show what a message looks like inside RabbitMQ. So we can see RabbitMQ, it pulled this one message. It was originally sent to the Exchange sample contract submit order. It was not redelivered. The message ID was assigned. These are the header properties that are part of RabbitMQ's transport. So I have the message ID. I have the expiration, which is 3000 milliseconds, which is 30 seconds. I have a delivery mode of 2, which, if I recall, is durable, which means it was written to disk. And it has a content type, which in this case is application VND MassTransit plus JSON. It also has, and this is actually kind of cool, but it has a header of MT activity ID. MassTransit with version 6 fully switched over to using diagnostic source activities for tracing. So anything that can connect and listen to those diagnostic trace events works. So like if you're using Azure App Insights or anything that connects a diagnostic listener and an observer to a diagnostic listener, it can catch and track, and it will pass all of these activity IDs between messages. So you're able to get a full end-to-end message flow with all of the telemetry through all of the different services that talk to your application. And then you can pull that data out, load it into some sort of tool. Azure App Insights works great, but there's plenty of other ways to do it. And you get that full call tree with all the time spent and every consumer, every message, whatever. This is something that's been needed for a long time, and now that it's there, it's like, especially with a distributed system where you have services all over the place, websites, etc., all of that stuff gets passed around. So pretty excited about that. It's pretty cool. The content type is replicated because this content type is the built-in RabbitMQ content type basic property. This is our header type. It's kind of duplicative, but older versions of MassTransit didn't write to this property. They only wrote the header value, so for backwards compatibility, we still write it to both. In this case, you can see the message is JSON. The different message headers are written in here. All of these identifiers are created using NewID, which is a GUID generation library that's used by MassTransit throughout. These are ordered identifiers. They should be unique depending upon the machine, process, and so forth, but the nice thing about these ordered identifiers is if I have to insert them into a database, they actually collate nicely into a primary key. That's why the numbers look very similar. If you were to call GUID new GUID, you would get completely randomized numbers in here. Here you can actually see that there's a sequence to them. You can see the source address was that bus address. The response address is the same address. The destination address is the exchange that it was sent to. You can see that it matches that value up there. As I mentioned in the first installment when we talked about message type names, the message type that's supported by this message is submit order, so you can see that in there. And then we have the actual message itself, which includes, the JSON serialization of that message contract. The expiration time, because we did set a time to live on the message, the transport will enforce that, but if the transport doesn't, it's also included in the message body, so it can be discarded if it's old. We do have the time that it was actually sent. And then we have that internal header here for that activity ID, because it gets written to the JSON envelope as well as the transport if those headers are available. Sorry, I should have muted. I'll get better. We also have a host block that shows the host that actually sent the message. So if you're troubleshooting, this is super helpful if you're trying to figure out like which machine is still running an old version of code or something like that. You can look at the message body and see that in there. But anyway, so the queue is empty because we responded. Now what we have is we have two services. We have the service that's running as a console app that is running our consumer, and we have the sample API that is actually running and making the request out to the remote service. Now, when I did the first installment, I did point out that by using the request client to submit the order, I'm really coupling these two services. I mean, the API is expecting a service to be available and to actually respond that the order was accepted or rejected, that the submission was accepted or rejected. I don't have to do that. I mean, I could make this order endpoint just flat dumb and say, you know what, I'm going to take whatever order you give me, I'm going to send it, and I'm just going to return an accepted. And they have the order ID. They can check the status later by hitting a REST endpoint that would query the status. I'll probably get into some ways to do that in a later episode, but for now I wanted to demonstrate how the request response works, because it also gives a really easy way to kind of show how the services interact. So I think that's about what I wanted to cover for this episode. I'm getting to the point where I think I want to take a little break for 10 or 15 minutes and kind of collect my thoughts for the next one. The longer break earlier was because the sun was shining and I had to get outside, so I got a little bit of sunshine, got a bike ride in, and now I'm going to take a break here and just kind of drink, collect my thoughts, and get ready for the next installment. I think the next thing I want to cover is how we could create a saga that's going to actually track that this order was submitted and allow us to actually do that query to find out the status of the order. So stay tuned. I'll probably be back in, I don't know, 10 or 15 minutes and start up another stream. So thanks for joining. Thanks for watching. And be sure to join the Discord channel if you have any questions. And we'll talk to you soon.